we are now going to show how we can add matrices together. And the important thing to remember here is that in order to be able to add or subtract, the orders of each matrix must be the same. So I can add a 2 by 1 to a 2 by 1, so I can add. Or I can subtract. But I can't do a 2 by 3 minus a 3 by 2. These aren't the same. They don't have the same row column order, and so they just can't be added. So the only way to add is if the number of rows matches the number of columns. So let's suppose for a minute that we have A equals 2 minus 1, 4, 5, 0, 9, and B equals minus 8, 2, 9, 7, 3, 6. Well, I want to find A minus B. Now let's start with A plus B, and then I want to find A minus B, and finally B minus A. So we're going to do 3 problems here. Well, in order to add or subtract, all I have to do is combine the aij's with the bij. So 2 minus 8 goes in the first row, first column. 2 minus 8 gives me minus 6. Second spot, minus 1 plus 2 is 1. Third spot is 4 plus 9, which gives me 13. 5 plus 7, which is 12. 0 plus 3, which is 3. 9 plus 6, which is 15, and I have finished my addition. Well, subtraction works similarly, except that we just subtract. So for my first step, I'm going to get 2 minus a minus 8, then minus 1 minus 2, 4 minus 9, 5 minus 7, 0 minus 3, and 9 minus 6. Well, when I evaluate each of these individually, it gives me the matrix 10, minus 3, minus 5, minus 2, minus 3, 3. And when I do B minus A, that just means I reverse the order. So it says minus 8 minus 2, 2 minus a minus 1, 9 minus 4, 7 minus 5, 3 minus 0, and 6 minus 9, which if you look closely, notice gives me the same thing almost. Every individual entry is the same, except for its sign is the opposite. So order matters, but the big thing about matrix addition is that we're just adding each column row pair, oops, let me make sure I draw that to the right one, to the correct piece. And as long as I do that, the addition becomes real easy.